September 1940, the English Channel. Gale force winds rip across Britain's southeastern coast, tearing loose the barrage balloons protecting cities from German bombers. These massive hydrogen-filled bags drift eastward across the North Sea, disappearing into the night. Within hours, reports begin filtering back through neutral channels. Power outages reported in Sweden. A radio station antenna reportedly toppled in Denmark. Electrical fires attributed to the balloons as far away as Finland. An accident, a nuisance. Except someone in Whitehall was paying attention. Someone realized that a few loose balloons had just done what Bomber Command struggled to achieve. They had knocked out enemy infrastructure without dropping a single bomb. What followed was one of the strangest and most cost-effective weapons programs of the entire war, Operation Outward. Between March 1942 and September 1944, the Royal Navy launched nearly 100,000 free-flying hydrogen balloons from England's east coast. Each one cost 35 shillings, roughly £2 when you include operational expenses. The damage they inflicted on German electrical infrastructure exceeded £1.5 million at minimum. One balloon, just one, destroyed an entire power station near Leipzig, causing damage worth 5 times the entire program's budget. The Germans called them Störballons, disturbing balloons. They had no idea how to stop them. The problem facing Britain in 1941 was brutally simple. Strategic bombing was failing. RAF Bomber Command was losing aircraft and crews at unsustainable rates while inflicting disappointingly limited damage on German industry. Each operational sortie cost thousands of pounds when you factored in aircraft, fuel, ordnance, training, and the irreplaceable value of experienced aircrew. A heavy bomber like the Lancaster required a 7-man crew. Lose the aircraft and you lost years of accumulated training, navigational expertise, and combat experience that no amount of money could rapidly replace. Precision bombing of specific targets remained beyond technological capability. Navigation systems could not reliably place bombers within miles of their targets at night. Bomb sites scattered ordnance across wide areas rather than concentrating on specific buildings. Area bombing caused destruction but rarely achieved strategic paralysis. Post-raid reconnaissance revealed that German factories resumed production within days or weeks of attacks that had cost dozens of British aircraft and hundreds of aircrew. Germany's war machine kept running despite everything Bomber Command threw at it. Meanwhile, German electrical infrastructure presented a tempting but frustrating target. The Reich's power grid connected hundreds of generating stations, transformer substations, and thousands of miles of high-voltage transmission lines. Damage any single point, and the grid could route around it. Damage enough points simultaneously, and the entire system would cascade into failure. But hitting enough dispersed targets required more bombers, more crews, more losses than Britain could afford. Power stations were small targets compared to cities, difficult to locate at night, and even harder to hit with the bombing accuracy available in 1941. The grid itself offered an alternative approach. High-voltage transmission lines stretched across the German countryside, exposed and undefended. Unlike factories that could be rebuilt or dispersed, the transmission network had to remain in place, connecting generators to the industries that consumed their output. Damage the lines in enough places and power could not flow. No matter how many generating stations remained intact, the question was how to damage those lines without expending the resources that made conventional bombing so costly. When Winston Churchill received reports of the accidental balloon damage in Scandinavia, he issued a characteristic memo to his war cabinet. "We may make a virtue of our misfortune." The Admiralty began investigating whether deliberate balloon releases could replicate and amplify this effect. Captain Gerald Bannister of the Boom Defense Division championed the concept against considerable resistance. The Air Ministry worried about collisions with RAF aircraft. One Air Ministry memo objected on grounds that attacks of this nature should not be originated from a cricketing country. The Chiefs of Staff finally approved the operation in September 1941. The weapon system that emerged was elegantly simple. Standard Royal Navy meteorological balloons, 8 feet in diameter when inflated, made from latex rubber that had been stored in French chalk to preserve elasticity. 100,000 of these surplus balloons sat in warehouses, useless for their original purpose, but perfect for repurposing. When filled with approximately 268 cubic feet of hydrogen, each balloon could lift roughly 18 pounds, enough to carry a weapon payload across the North Sea. Two payload types were developed. The first was a trailing wire system designed to short-circuit German power lines. 700 feet of hemp cord connected to 300 feet of specially straightened steel piano wire, 15 gauge with a breaking strength of 1,000 pounds. This combined 1,000-foot trailing length would drag across the German countryside as the balloon descended with a calculated 10 to 75% probability of contacting high-voltage transmission lines. During trials at the Admiralty Research Establishment, these wires initiated electrical arcs capable of spanning 15 feet, melting aluminum conductors and destroying transformers on contact. The incendiary payloads came in 3 varieties. Socks were 6-pound canvas bags filled with wood wool soaked in paraffin wax, 3 per balloon, designed to catch tree crowns and burn white hot for 15 minutes. Beer payloads contained 7 to 8 half-pint glass bottles of self-igniting phosphorus, white phosphorus mixed with benzene and rubber that spontaneously ignited when the glass shattered on impact. Jelly was a 1-gallon metal canister of incendiary compound that created a 20-foot radius fireball upon ignition. An ingenious altitude control mechanism governed each balloon's flight. An internal cord attached to a spring-loaded valve would tighten as the balloon expanded at higher altitudes, releasing hydrogen at approximately 25,000 feet and triggering gradual descent. A slow-burning fuse, calibrated to estimated flight time, controlled payload release. Transit time to German-controlled territory was approximately 8 hours. 3 launch fights operated along England's southeastern coast, positioned approximately 50 miles apart on a north-south line. The primary facility at Felixstowe Ferry Golf Club in Suffolk operated under cover of HMS Beehive, a Royal Navy shore establishment at Landguard Fort. The golf course provided open ground for balloon inflation, while the naval cover designation explained military activity to curious locals. Secondary sites opened at Old Stairs Bay near Dover in July 1942 and at Waxham in Norfolk, north of Great Yarmouth. The workforce was predominantly female. Of approximately 233 personnel at each site, 140 were Women's Royal Naval Service ratings, known as WRENs, supported by 80 Royal Marines for security and 13 naval officers for command and meteorological coordination. RAF Balloon Command supplied hydrogen via truck-delivered pressure cylinders, while Naval Meteorological Services provided the essential wind forecasts that determined when launches could proceed. Launch procedures required meticulous safety precautions given the volatility of hydrogen. Balloons were inflated inside 3-sided canvas and wood shelters with water continuously sprayed on the latex to prevent static electricity from triggering explosions. Personnel wore flash jackets, hoods with copper gauze face panels, fireproof gloves, and protective hand cream. Despite these measures, many workers suffered burns, though no fatalities occurred throughout the program. At peak efficiency, individual crews could launch 10 balloons per hour. The operation achieved rates of 1,800 balloons in 3 to 4 hour periods by August 1942. Weather requirements included westerly winds at altitude, which occurred 55% of the time, and ground winds above 10 miles per hour in target areas. Easterly winds that might have enabled German retaliation occurred only 38% of the time, a natural defensive advantage. Now, before we see what happened when these balloons reached Germany, if you are finding this interesting, consider subscribing. It takes a second, costs nothing, and helps the channel grow. Now, let's get into the combat record. The first balloons launched on March 20th, 1942. Within days, British intelligence received reports of forest fires near Berlin and Tilsit in East Prussia. The incendiary campaign had begun, but the wire-carrying balloons would prove even more devastating. On July 12, 1942, a single balloon launched the previous day struck a 110 kilovolt transmission line near Leipzig. The trailing wire caused a phase-to-phase short circuit that German protection systems could not handle. German protection schemes designed primarily to limit single line-to-earth faults proved ill-suited to the phase-to-phase arcing that balloon wires created. At the nearby Berlin power station, a circuit breaker failed to trip quickly enough. One of the station's 16.5 megawatt generators was thrown out of synchronism and began vibrating violently. According to Admiralty records preserved in file ADM1/1984, the rotor shaft bent, creating mechanical interference with the fixed stator and triggering an explosion followed by an uncontrollable fire that completely destroyed the entire power station. Photographs in the National Archives show the catastrophic rotor damage that resulted when synchronization was lost. The damage was catastrophic. 250 megawatts of generating capacity knocked out for an extended period. Material losses estimated at £1 million, not including the value of lost production. This single incident inflicted damage worth approximately 5 times the entire Operation Outward program cost. German records documented the escalating chaos. 520 major disturbances on high voltage lines of 110 kilovolts and above occurred between March 1942 and January 1943 alone, a period during which approximately 25,000 balloons had been launched. Recording of incidents on lower voltage lines was abandoned because they were too frequent to track. In occupied France, 4,946 power interruptions were documented over the program's duration. When balloons severed lines on one side of transmission pylons, the unbalanced mechanical forces sometimes collapsed entire towers. The economics were remarkable. According to Electrical Power and Energy magazine's detailed analysis, each balloon's total operational cost was just over £2. Compare this to Bomber Command's several thousand per sortie by contemporary accounting. The article concluded that in some months, there was more damage done to electrical systems by the balloons than there had been by bombers, and at a much lower cost to Britain. German responses consistently proved counterproductive. The Luftwaffe dispatched fighter aircraft to intercept balloons. In one documented case, up to 250 fighters assigned to a single interception effort. The fuel and ammunition costs vastly exceeded what Britain spent producing the targets. Pilots found the balloons frustrating to engage, drifting silently at altitudes that required significant climb time to reach. Each hour spent chasing balloons was an hour not spent defending against conventional bomber raids or supporting ground operations. Anti-aircraft batteries engaged balloons at altitude, again expending resources far exceeding the balloon's value. The Germans tried searchlights, observation networks, and early warning systems, none of which could reliably predict where the wind-carried balloons would descend or which transmission lines they might contact. Electrical engineers attempted systemic solutions that backfired dramatically. Increasing the sensitivity of high-voltage circuit breakers caused them to begin tripping from bird strikes and normal weather events, worsening power reliability. The cure became worse than the disease, creating outages where balloons had not even reached. Most disastrously, a high-ranking Nazi engineer designed new transmission line clamps intended to release conductors safely if balloons caused unbalanced forces. Over 1 million clamps were manufactured and installed across the German grid. The design proved fatally flawed. Normal wind and ice loading triggered the release mechanism, causing conductors to drop and creating additional outages. Due to the engineer's political position, it took considerable time for transmission engineers to prove the clamps were causing damage. Eventually, all had to be removed and replaced at enormous expense and disruption. A 1943 order from the German 65th Infantry Division captured the frustration. The enemy is using recently balloons, carrying beneath them spiral coils of wire with a hook at the end. If these balloons become entangled in power lines, serious shorts occur, and often the damage lasts for days, causing work of units and state of readiness to be held up. The harassment forced Germany to maintain standing emergency repair crews across the country, assign fire-watching personnel throughout forests and heathlands, and periodically shut down power lines preemptively when attacks were anticipated. Each response further disrupted industrial production and military readiness. Post-war assessment by a team from Britain's Central Electricity Board sent to Germany to examine captured records found documented damage of at least £1.5 million. They emphasized this was a minimum estimate. Records from the Soviet occupation zone were unavailable. German documentation became increasingly unreliable after 1943. Lower voltage incident tracking had been abandoned entirely. The team concluded that the result of the operation was out of all proportion to the manpower and material employed. British military officials described the program's impact as equivalent in naval parlance to the loss of a capital ship. The Japanese launched their own balloon bomb campaign from November 1944, the Fugo program.
Japan released approximately 9,000 balloons intended to cross 5,000 miles of Pacific Ocean, riding the jet stream from the Japanese home islands to North America. The sophisticated paper and rubberized silk balloons with barometric altitude controls cost significantly more than British weather balloons. The engineering was impressive, using multiple sandbag ballast drops controlled by atmospheric pressure sensors to maintain altitude across a 3-day transoceanic journey. But the results were minimal. Fugo killed 6 American civilians, a woman and 5 children who discovered a downed balloon in Oregon in May 1945. The American government suppressed all news coverage, denying Japan any feedback on where balloons landed or what damage they caused. Operation Outward caused massive documented infrastructure damage with no confirmed casualties, a crucial distinction for a program targeting electrical systems rather than population centers. Britain achieved far more damage with simpler technology, shorter distances, and a fraction of the cost. Several factors made Operation Outward uniquely British. Prevailing winds at operational altitudes favored westward drift 55% of the time, while enabling potential German retaliation only 38%. British analysis revealed that German power grid protection schemes were particularly vulnerable to the phase-to-phase shorts that balloon wires created, making Germany more susceptible than Britain would have been to similar attacks. The program embodied Churchill's doctrine of making virtue from misfortune, repurposing surplus materials to achieve strategic effects with minimal risk to British lives.
The Wrens, who inflated and released these balloons, developed their own traditions. According to veterans interviewed for the Imperial War Museum Oral History Collection, they wrote rude messages on uninflated balloons that became prominently visible as the latex expanded, messages directed at Hitler and his inner circle. Their ironic theme song was "I Don't Want to Set the World on Fire," especially apt given that half the balloons carried incendiary devices. When winds shifted unexpectedly, one balloon blew back over England and knocked out power to the entire town of Ipswich. British newspapers, unaware of the secret operation, attributed it to Hitler's latest new weapon. Operations continued for 899 days until September 4, 1944, when hydrogen supplies were diverted to support the Normandy invasion. By then, 99,142 balloons had been launched. The operation remained secret for decades after the war. Remember those loose barrage balloons that drifted across the North Sea in September 1940? An accident that could have been forgotten, dismissed as an inconvenience caused by bad weather. Instead, someone in Whitehall asked a simple question: what if we did this on purpose? What if we turned an embarrassing loss of equipment into a weapon? The answer cost Britain roughly £220,000 over 2.5 years. It cost Germany power stations, transmission networks, 1 million useless protective clamps, countless fighter sorties, and the constant anxiety of attacks that could come from anywhere at any time that no air defense could stop. Post-war investigators concluded the damage was equivalent in naval parlance to the loss of a capital ship, achieved not through naval battle but through weather balloons and piano wire. Operation Outward proves something that military planners often forget. The most effective weapon is not always the most expensive one. Sometimes it is a weather balloon. 35 shillings worth of latex and hydrogen drifting silently across the North Sea to wreck the enemy's infrastructure without a single bomb, without a single British casualty, and without the Germans ever finding a way to stop it. British engineering was not about building the biggest or the most sophisticated. It was about solving problems with whatever was available, turning surplus weather balloons into strategic weapons, making virtue from misfortune. That was the real lesson of Operation Outward. And that was why those cheap British balloons destroyed German power stations while the Reich's most advanced defenses watched helplessly from below.